Welcome to Math 201, Lesson 2.4 on Interpretations of the Derivative. Following data for h of t gives the number of hours of daylight in Boston, t days after January 1st. Evaluate and interpret h of 20. So this is just straight function notation, algebra, no calculus for this question. So h of 20 is just asking for the y value or the h value when t is 20. So we look in the t column, we find 20, we give the h value, 9 and 34/60ths, which is hours of daylight, 9 hours. And I put these all in 60ths because then you can easily interpret it to minutes. So it's 9 hours, 34 minutes of daylight in Boston. So that's our interpretation. So 20 days after January 1st, which would be January 21st. There are 9 hours and 34 minutes of daylight in Boston. Okay, so next I want to estimate and interpret h prime of 20. So remember, h prime of 20 would be the slope of the tangent line at 20, or the instantaneous rate of change at 20. We don't have a formula to be able to do the limit calculation as h goes to 0. So instead, I'm going to do the smallest possible h I can, which would be the average rate of change from 20 to 30. That's the smallest interval I can do to estimate h prime. So h prime of 20, remember the limit definition would be the limit as h goes to 0 of h of 20 plus h minus h of 20 all over h. Okay. And I would let my h, my interval from 20 to 20 plus h, get as smaller and smaller and smaller and smaller and approach 0. Okay, but the smallest interval I can do from 20 to 20 plus h is 10. This is all the data I have. I can't make a smaller interval, so I'm going to have to use this interval of 10 to estimate my instantaneous rate of change. So this is going to be approximately equal to, I'm not going to write the limit anymore. I'm just going to do the average rate of change. So I'm going to do h of 30 minus h of 20 over 30 minus 20, which is 10. Okay, and that's going to come out to h of 30 is 9 and 55/60ths minus h of 20, which is 9 and 34/60ths over 10. So that's 21 over 600, 21 over 60, 21/60ths um, divided by 10. And that is 21 over 600. Okay, and to interpret it, I am going to put some units. Okay, I think the best way to interpret is to add units to figure out what these numbers mean. So these are hours, and these are days. Okay, so that's hours of daylight um, divided by 10 days. Okay, so 21/60. So again, this is hours and days. So 21 over 600 hours per day. So 21/600 hours per day. That tells me that the daylight is increasing by 21/600 of an hour per day on January 1st. So let's write this out very clearly what this means. So 20 days after January 1st. So on January 21st, okay, because this was h prime of 20. So 20 days after January 1st. On January 21st, one additional day yields approximately 21/600ths of an hour increase in daylight. So I'm going to say IE, okay? It, that means that January 22nd, there will be approximately 9 hours and 36.1 minutes of daylight. Okay, and I got that number by adding 9 and 34/60ths plus 21/600ths. So I took how many daylight hours there were on January 21st and added this number that you should be adding per day approximately based on the derivative. Some things that you should include when you are interpreting a derivative are your units, some real world terms, and the change in input giving a change in an output by an approximate amount. Okay? And whether that amount is an increase or a decrease. So things to avoid would be the words always, each, or every, because it's not true that every additional day will yield 21/600ths hours of daylight, additional hours of daylight, because that rate of change is constantly changing. Okay. So in January, on January 20th, the instantaneous rate of change is approximately 21/600ths. But in June, that rate of change is much faster. Okay, so it does not stay constant. So you don't say always or each or every. Take a few minutes to work through this activity for section 2.4 before coming back to watch this video if needed. Go ahead and pause your video now to work through this activity. Okay, you're a data analyst for a marketing company, and you're studying the relationship between the cost of an ad campaign and the customer satisfaction percentage of the focus group. Armed with the data, you're preparing a presentation for a variety of non-mathematical managers. Let S equal P of C be the function giving the customer satisfaction percentage for an ad campaign costing C $1,000. So interpret P of 50 equals 66. So there's no derivatives in here, so I don't have to think about rates of change. This is just the function itself, S equals P of C. So 50 is the C, which is the cost of the campaign. So when the campaign costs $50,000, customer approval rating, which is the S, is 66%. Now, what would the units be on P prime of C? So to calculate P prime of C, we would calculate a difference quotient, change in output over change in input. So P prime of C is a change in output over a change in input, right? It's the slope of a tangent line, and the tangent line is going to be change in output over change in input, which in this case is change in approval over change in cost. Okay, and the units on approval is percentage, and the units on cost is thousands of dollars. So now we want to interpret P prime of 50 equals 1. So 1 is 1% per $1,000. Okay, so let's just, the 50 is is the same input as before. It's when we spend $50,000. And then let's think about the units on the 1. This is 1% per $1,000. Okay, so you get an additional 1% approval for every uh, for an increase in $1,000 spent. And I should not have said every, right? I caught myself right there. So when we spend $50,000, an additional spend of $1,000 would yield approximately 1% increase in approval. Okay. I.e., P of 51, right? So P of 50 was 66 from the previous question. P of 50 was 66. Let's write that down. We knew that. Okay. So P of 51 should be approximately 67. So if you spend $51,000, you should get an additional 1% in approval, so 67% approval. Okay, recall, same function, S equals P of C gives customer satisfaction percentage for an ad campaign costing C $1,000. On this side, you'll think about the function P inverse and how to interpret the information it gives. Okay, so what will be the input and output for P inverse of S? So inverse functions just reverse input and output. So it used to be that C was the input, cost was the input, and approval was the output. So that is going to shift. So my input is going to be percent approval, okay, and my output is going to be cost in thousands. Interpret P inverse of 70 is 55. Okay, so my input, again, this is approval percentage, and my output is the cost in dollars. So this says to get 70% approval, we spend $55,000. What are the units on P inverse prime of X? So the answers to the first question should help, where I talked about the inputs and the outputs of P inverse. Okay, so remember P inverse prime is change in output over change in input. And for this problem, input was approval and output was cost. So this is change in cost per change in approval. Okay, so my units are going to be thousands of dollars per my approval units is percent. So to interpret P inverse prime of 70 equals a half, um, I have to know that that 70 is an input to the inverse, which means it is an approval rating. Okay, so we want to say when approval is at 70%. Okay, so that's the beginning. Explain what the input is. Okay, so an additional 1% approval costs a half of $1,000. So look at this a half here, and we know that its units are um, thousands of dollars per 1%. Okay, so to get an additional 1% approval, um, costs approximately half $1,000, which is $500. Okay, so i.e., since P inverse of 70 was 55, P inverse of 71 to get one additional percent approval it'll cost approximately 55 and a half thousand dollars, right? An additional $500.